Hey, good morning. We're going to do a quick lesson here. Our last lesson is on what are step functions. So to get us started, let's just take do now from yesterday. What's the average rate of change over a given interval? Now, average rate of change is really just finding the slope, but I need it over this interval from -1 to 5. So -1 belongs to which piece? It belongs to this piece. Because x is less than -2, for this piecewise belongs here. So I need to know what that evaluates at to figure this out. So -3 plus 1 is -2. So the first point is -1, -2. Now, if I want to find where this function evaluates at 5, that's going to belong to this piece. So I need to do -6 times 5. And then add 10. So that's -30 plus 10 is -20. And so my second point of this piecewise function is 5 comma -20. And remember, to find average rate of change, we simply just do the slope formula. So change in y over change in x. So change in y would be -2 plus 20. And change in x would be -1 minus 5. That positive 18 over -6, which gives us an average rate of change of -3. And that is the answer. The average rate of change is -3 over this piecewise function. All right, so let's consider a new piecewise function. I call this a unique piecewise function because each piece is actually a horizontal line. We have these two horizontal lines, so f of 0 belongs to the first set, so it evaluates at 2. F of 2 evaluates also at 2 because it's found in this interval from 0 to 5. F of 5 is our tricky one because it looks like it belongs to both sets, but if you zero in on that equal to symbol, you'll see that f of 5 evaluates at 6. And then f of 7 is also at 6, and f of 10 is also at 6 because 10 is included in the set. So let's graph a step function and take a look at what this looks like. So our function from 0 to 5 is at 2. So at 2, from 0 to 5 is at 2. So I have a point here. And then I have all these points all the way for 1, 2, 3, 4, 5. And then it's open there. And we're going to connect this with a straight line. That is the first piece to our function here, is f of x equals 2 in between 0 and 5. And then it jumps up or steps up to 6 between 5 and 10. So I'm going to jump up to 6. We're at 2, 3, 4, 5, 6. So it's going to be closed here all the way to 10, which is also closed. And so we are going to connect those as well. Now, this step function only had 2 pieces. We can get step functions that have a lot more pieces than this. So this is the graph f of x, and we are done. So now it makes more sense as to why f of 0 is 2, f of 2 is 2, f of 5 skips the open circle and goes up to 6, f of 7 is 6, and f of 10 is also 6. So what's the definition of a piecewise function? A step function is a piecewise function containing all horizontal pieces. This type of function resembles a set of steps and is discontinuous. It's not continuous, cannot be drawn without removing your pencil from the paper. So let's take a practice problem set number 1, where we have a piecewise function that looks like it's all horizontal pieces, so it's going to be a step function. So f of 0 belongs to which of the 3 pieces? F of 0 belongs to 2. F of 3.5 will evaluate at 5. F of 2.7 will evaluate at 2. And f of 5 will evaluate at -4. Now, a little confusing, but once we see the visual on what this looks like, it becomes a lot easier. So from 0 to 3, I am at 2. So I'm going to put a big dot here from 0 to 3, and this is going to be open at 3. and I'm going to connect these with a nice straight line. That's the first piece. And then at 3, it jumps up to 5, and it's going to be closed here at 5, and it's going to be open here, and we are going to connect this. And then lastly, it jumps down to -4, or steps down to -4, and that is from 5 all the way to 10. So 1, 2, 3, 4. We are down here, and it's closed here at -4, and then it's going to go all the way up to 10, and that is our step function. The domain of this function, the domain of our function goes from 0 all the way to 10, so we will say x is in between or bound between 0 and 10, and the range of our function is simply just 3 values. It's 2, 5, and -4. Let's put them in numerical order. So -4, 2, and 5 are the only 3 outputs you will get, which makes sense now that f of 0 is at 2. F of 2.7 is also at 2. F of 3.5 is now jumping up to 5, and f of 5 jumps all the way down to -4, and that is it. So the next skill we want to work on is defining a function here. So this is our piecewise function. We'll say y equals, and we have 3 pieces here. So it evaluates at 4, it evaluates at 2, and it also evaluates at -3. And the big part is getting the domain right. So this one is for all x's that are bound, 2 closed circles right there in between -4 and -1. It evaluates at 2, both open circles from -2 to 2, and it evaluates at -3 when we are less than or equal to 4 and greater than or equal to +2. And that is our first piecewise function there. The second one is going to be similar, but slightly different. So our piecewise has 3 pieces. Now it looks like it has 2 pieces, but don't forget about that single point there. So it evaluates at -1 when x is less than 0. It evaluates at 0 when x is equal to 0. And it evaluates at 1 when x is greater than 0. So this is a little bit of a different piecewise function. All right, so the last 2 things we're going to do today are just 2 piecewise functions in real-world context. So here they come right at you. The parking garage rates in New York City. So how much does it cost to park for 30 minutes? Well, if we go to 30 minutes, which is in between 0 and 1 hour, it evaluates at 6. So we're going to say it was $6 for the 30 minutes. It looks like anything for an hour or less is $6. And then if you look after 1 hour, it jumps up to $12 for another hour. And then after about the second hour, it jumps up to $15 indefinitely for as long as you stay there. So that's not so bad. So a person checks in at 5:45 p.m. and checks out at 7:45 p.m. That is going to be 2 hours. So we owe them $12. Just be careful not to say 15. It's open at 15 and closed at 12. Now, if a person pays $15 for parking, how many hours did they park for? Well, we don't know the answer to that. So we're going to say for more than 2 hours. That's all we know. It has to be more than 2 hours. And that is a quick example of a real-world piecewise step function here. All right, moving on to our last question. A local amusement park charges the admission fee based on age. Graph the amount of money a person would have to pay for admission based on their age. So here's the price range. If you're 3 and under, you're free. If you're 8 and under, you are $4. And 16 and under, $8. 17 and older is $12. And so here's where it's a little bit tricky, is you might say, okay, it's $0 for 3 and under, and you'd be right. But where does 3 and under actually start? Does 3 and under start at 3? I want you to think about that for a second. 3 and under actually starts at 4. So the moment you hit 4, let me make that a little better. The moment you hit 4, it's open there, it's open here, and it's connected here. So it's $0 in between 0 years old and 3 years old. And then after you hit 4 years old, it jumps up to $4. And then it stays there until you are 9. Because think about it. If you're 8.5, you're still 8. So it has to go past the 8. It's got to go all the way to 9. So we have to jump up to $4. We're going to close it off here. Because the second you hit 4, remember, 1 day shy of your 4th birthday, you're still considered 3. So once you hit 4, it jumps up to $4, and then it goes all the way to 9, and then it will be open at 9, and we are going to connect this line here. And then what happens is from 16 and under. So that means we have to jump up to $8. $8. So we're at 4, 5, 6, 7, 8. We're going to close it there. And we want to go all the way to 17 because it's 16 and under. So we're going to go all the way to 17, which is right here. That's going to be open. And we are going to connect this with a nice line. And then over 17 is $12. So we're going to jump up to 12. Once you hit 17, it is going on indefinitely in that direction for as old as you can possibly be. And that is a step function in real world context. And you could ask a lot of questions based on this. You know, how much would you pay if you're 12? Well, look at the graph. Go over to 12 and you jump up and you will be at $8, which makes sense because if you're 16 and under, you should be paying $8. All right, so that is the end of this lesson. Step functions. See you later.